Okay, welcome to our session for the next 75 minutes, and good morning, everyone. So we're going to do a quick intro, then I'm going to tell you what you're expecting from the next 75 minutes from us. And I'm Lindsay Allen, and I'm from the SQL engineering team, and we're responsible, collectively, we're responsible for Azure SQL database business and the engineering team.
And my name is Joachim Hammer. I'm in Lindsay's team, and I'm primarily responsible for security and privacy, but we're all, as Lindsay said, collectively driving the business. You'll hear from me a little bit later. I'll talk about one of the customer stories.
Good morning, everyone. My name is AJ Jagannathan. I've been with SQL for almost 19 years, ever since SQL 6.5. Worked with a lot of customers, and looking forward to sharing some of our success stories and how you can take back some from us.
Alain Domal, I'm the technical product manager for SQL Database, and I look after a lot of the content we have and like sort of the positioning that we do for SQL Database, and I'll be covering some of the sort of the new business models and things that we've released recently.
Thank you. Thanks. So we're going to get started, and we'll try our best to do fast transitions so we can get as many content as we can through in the next hour or so. And here we thought about this session, right? Because it took you lots of time and effort to come to our conference, come to our session, and we thought to share with you. And here's what we come up with. We figured, in your real life, in your day job, right? You really actually have to build something. You build something for your customer, and your business grows, your customer business grows, and in able to do that, you actually want to try to pick a platform of choice, right? Either that database or OS or cloud these days. So I thought we would present this from a customer perspective. And we're not going to go run down of our features, right? I think it won't be similar to normal Microsoft sessions. Start with a feature list, tell you how great we are, and we are going to tell you how great we are. But we're going to tell you from customer perspective. So we're going to start with the customer, work backwards. And so we are going to spend lots of time, do some deep dive of customer references, and you get to talk to some of our customers real time. The customer themselves cannot make it here, so they'll be on Skype. And so we have tons, literally, references. So we have to pick and choose, right? Because we only have 75 minutes altogether, I have to set context. So we think we can fit in 5. Let's see how good we do. And then as everybody probably on top of their mind, they look at all the great case study, the platform, then how do I use it? How do I buy it, right? And lots of things are free, but certain things do end up on your credit card bill. So the business model is important. We'll give you an update because we changed our business model. We try to make it simpler for you to use. And then we're going to wrap up. Hopefully, we're going to save 5 minutes or so for QA. So as I said, we're going to go from the customer perspective. And the SQL database and service are a platform. After all, it's a platform. We don't build apps. You build apps, right? You run apps, and you design apps for your customer-specific scenario. And we talk to literally thousands, hundreds of thousands of customers over the collectively, how many years we've been in SQL? I've been in SQL since forever. I've been in Microsoft 24 years. Yeah, I spent most of those time in SQL, and yeah, everyone been here for more than 10 years. So we've been talking to many, many customers, and we're trying to simplify things, right? Because we try to build a platform. We realize there's really 3 categories of questions that people asking when they're actually choosing a platform instead of building it themselves, right? Everybody can go write, start from Linux kernel, write your OS, right? It's just going to take a long time. And then every line of code you write, if you actually get somebody to use it, you end up have debug and support it. So there's also always this fine balance. What code you want to write yourself, and what you want to just pick it up and use it, right? So usage scenarios, that's basically what application you're writing for, right? And either from the social networking application or some mission critical application controlling nuclear reactor scheduling. And then what features you will need. You prefer not to write yourself, right? And hopefully it's easy to use. And after all build, your app becomes super popular, you're going to run this as a service. Costs become a problem, right? Because you can't run everything off your desktop under your desk. So this is 3 buckets of things, really, and people looking at. And hopefully, you don't actually have to pick 1 feature per product, right? That's end up, you have too many one-trick ponies, going to be very difficult to manage. So overall, too many applications. So we think about, our segmentation of our applications. There's enterprise applications serving their customers or internal customers, and they try to move to cloud. Then this is a category of applications. We call it a cloud-born SaaS application, software as a service, right? Very typical one, Facebook. They're running on their own cloud, right? There's many cloud. So they designed as a distributed cloud application, and because they're large enough, they run on their own thing. And then there's internal enterprise application, and there's lots of typical like ISV software application been running for years and years, like SAP, right? ERP application or Dynamics, mostly are on-prem in customers' data center. And now they actually all looking at making it a SaaS application in the cloud. So it ranges from your typical ERP, CRM system, social media, e-commerce, and all the way to government and education. And there's a huge range of applications, millions of ISVs. There's 20 million developers on this planet. Apparently, last survey, there are 20 million developers, everybody's writing code, so there's a lot. And so how can we actually abstract to figure out a platform actually help as many developers as possible, right? And goal for platform is driving for popularity. Popularity is by features and reliability. So we believe we're a data platform, and all application at some point we need data, right? Even Halo needs data. When we started working with Halo games, and one just start and everything in memory, and because it's the first shooter game. And when that grows, they realize that they need the data, they need the stats, people need to compete, and they need the basic data to actually manage the platform. Then they need AI to actually how can actually attract more players, right? So data is defined by volume, velocity, and variety. You can call this big data problem, traditional data problem, but there are 3 axes of vectors of data, and there's 3 distinct classes of questions. Generally, you want a data system to answer for you. Doesn't matter what kind of type of app you're building. That's what you do, right? You're building is the very innovative application. But eventually, when you need the data to be persistent, don't get lost, you want these kind of questions to be answered by your system for your customer. What is happening now, right? What is happening now? And what has happened over a lifetime or some arbitrary period of time of your system? And then this is the most popular thing these days related to AI and the crystal ball, right? Everybody likes crystal ball. What would happen if I wonder if this happened, right? So there's 3 distinct class of questions, and there's an implicit requirement from all of this. Number 1, concurrency. And we learned it the hard way from our data warehouse days, right? And we figured, query is complex. 8 concurrent users is good enough. It's far from good enough, right? We've been still trying to figure out, don't design our system into limited concurrency. The concurrency, think about, we need to serve the planet, right? And or Mars or something. And then another implicit requirement, especially from the first, what's happening now, is the latency. Latency requirement for both read and write. We're not talking about IOPS, right? I think sometimes we get stuck in this IOPS. IOPS, I normally, when I talk to our storage engineering team, I tell them, IOPS, there's good IOPS, it's bad IOPS. SQL need good IOPS because IO per second is no good. If you literally take like a 10,000 disk, get a 10,000 IOPS, we don't want it, right? because that's I/O per second. If you do 1 I/O per second, that's super slow. I might go to fries, buy my own disk. And ideally, you want a comprehensive solution and serve all these scenarios. How many times your customer actually started by give you very, very succinct, crystal clear requirement that never changes? Raise your hand. Nobody. I never see any customer able to come to me and says, this is the system requirement, never ever going to change for the next 10 years, right? It generally the changes every other day. And as soon as, right, you show them a demo, they go say, I want something else, right? And they don't know what they don't know. We don't know what we don't know. So the best platform is, since you have to build on it, you don't really know your application requirement like 100% of all the time. And you want your platform to be flexible and to be able to respond to the change, to have enough features, use it or not, it's there. When you want to use it, it's there, right? And you don't actually have to go through new acquisition process just to get to it. So over 28 years, SQL Server have the same strategy. We want everything built in. And the SQL Server is everything built in. We add more new features and to support a new modern workload. So lots of the new features we added over the years is to support the new workload. We realize application scenario changes, the workload changes because the business changes. So, and with the same quality and the same scale, same performance. So if you pick SQL, SQL is one platform, no FAS. It's just SQL. You buy SQL and you buy course or whatever, and it runs on your hardware or runs in cloud, and give you the performance and the intelligence you're looking for. This is actually, we put this as a sample code because IoT is everywhere, and IoT is not really new, right? It's not that new. The internet part is fairly new. The fast internet is very new, right? The internet generally is very slow. I remember the olden days, you have to dial a modem, right? So my teenager doesn't really know what a modem is. So the world changes very, very fast. So the fast internet is new. And that's why actually the chances of leverage the engine, the fast engine for Internet of Things, oh, it doesn't work. Sorry, I tried to, I don't know. It's actually become a reality. So look at this. This is from a customer case. It's IoT. It's a typical, your oil and gas field have all the devices, and the drilling and the natural gas, the field and the pipeline, everything. They need monitoring these devices. In olden days, these signals have to come through a specific network, generally in the field, at these radio frequency network, right? And the company have more money, use military grade, and the company have less budget, use less powerful radio frequency, then you can transfer the bandwidth is very limited. You can transfer very limited amount of data, so use old computer to build all that, right? But the system actually is expanding in terms of, you see drilling everywhere. And then we need to be conscious about our environment to understand the environmental impact. And so there's lots more data need to be analyzed, right? So the data need to be actually pumped to one place because the more machine you use and the more expense and cost there is, right? So it entices people to analyze less data. Even regulators come to the oil and gas company and need more information. They have to be cost conscious, right? So with the SQL, this is one single database. I think I have the size of the actual hardware. So this is one single database. And for HTAB, be able to actually upload, insert, this is single row insert, to in-memory table, 1.4 million rows per second. And this is not a very interesting part, right? The interesting part is this is end-to-end solution. At the same time, we actually offload and the same data insert to column store, to on-disk column store, so we don't actually eat up the memory, right? Physical memory. We have a limited amount of physical memory in Azure, so we actually offload to physical disk, allow you to do these AI, like predict analytics using machine learning, and do the regular analysis, like a data mart, data warehouse type analysis, and use aggregates, a complex query, and use column store. And SQL have this all-in-one engine, right? You don't actually have to create a separate database. You don't need a separate database column store, separate database for in-memory, separate database for graph. We actually have graph. Very less known fact, actually, I was surprised. We released the graph in SQL Server 2017. Before that, it was in Azure SQL database. So if you actually need like a CRM and the kind of customer relationship type of application features, graph is built in SQL Server. You literally don't need to create another database. We're not asking you to create another database for JSON. It's native type. You don't need to create another database to run graph. You don't need to create another database if you use Ruby on Rails. And you don't need another database to connect to Spark. We released the Spark connector. So you can pick your favorite thing. So I just thought, since nobody knows about SQL have graph, and we just want to show you, these are some of customers. We literally have thousands of databases have graph in Azure SQL database. Well, of course, we have more than 4 million databases. Several thousand is like 6,000, 7,000 graph databases, not so exciting comparably, but it's a lot. It's like 6,000, 7,000 databases running graph in production in Azure SQL database. This is OGA features, right? These are customers actually running their business application using graph. In SQL Server, this is just in SQL DB. We don't see a lot of telemetry from SQL Server. Generally, customers put their database behind firewalls. So as I said, the sample code we had in GitHub and the blog is from real customer. This customer is SAS SV. Sorry. SAS SV and the name Quorum. And they're running this managed SCADA system for oil field, oil and energy drilling. And for lots of these oil exploration and production system, they need to be responsible for the environment, right? They also affected by the environment because California has had earthquakes. And if they just talking about simply scale out, end up they're going to have too many CPUs and too many computers they cannot manage. They can't afford it, basically, right? So efficiency is important. They want to talk about have a database can manage thousands of devices. So they choose in memory, and it's highly efficient, and they can reduce the usage when they flipped from disk to in-memory, and the resource usage reduced by 70%. That's actually money saved to their bottom line. And this is from the VP, right, and the comments, and they're really, really happy, impressed. They've been running in SQL Azure for 2 years now using memory, OLTP, and column store. And the link to case study, and because of they use SQL Azure, they don't have to worry about infrastructure, and the cost is super low. They have 10x growth in their customer base, and without actually increase their cost. Then the case study is public, the sample code is there, and this is the basic architectures in the blog as well. When you have thousand devices emitting tens and hundreds of thousands of events, right? This is typical IoT. And inject into a memory table, and we offload at the same time, and to column store on disk, so enable for your analytics. All this together without actually need to leave this database, same database, a single database. And this is how we actually run digital crime unit in Microsoft as well. So we do monitor internet, we work with government to, and I thought I'll bring up this slides. I know I've been rushed because I have 3 more speakers coming up. So why not run your database just in your SQL Server in VM, right? Because you know how to do it. And it's the growth and the amount of work you have to do. Look at the left side. We actually, the entire list up to the bottom couple of rows, actually most DBA call it database chores. And how many DBA really enjoying go sort out the hardware patching and your BIOS need update and all that headache, right? And the patch Tuesday, and take your system down. And we're taking care of all of that for you. And HA actually costs additional money. Because if you enable to set up HA, just say you're HADR expert, right? You actually literally have to set up your network, your machine, and your topology to sustain HADR. And here's the thing. Lots of actually, what should I say? We noticed many customers forgot to actually do the test of failover, right? It's wonderful to have everything designed on the chart, right? And implemented so you have your happy path, right? Generally, when disaster hits, your happy path will break. So the actually disaster recovery and HADR dry run is important. We do that for you on our infrastructure. And we have lots of AI intelligence built in our PaaS service, taking care of lots of more problems. So you don't actually need to worry about it, right? We have lots of bots, so we have lots of expert systems, and we have lots of alerts going on. Everything is built from ground up across all 43 regions, 100-something data centers worldwide. And we build on top of Azure infrastructure, service fabric, and we have HADR, security, auditing, and all these compliance and data privacy features across the entire platform, right? Then the SQL, we took all the SQL Server goodness, added all the PaaS capabilities. Because of the extensible and scalable, flexible platform we built, we're able to lit up other databases, services on top. We have data warehouse. We took the scale-out MPP query engine, runs on top of SQL. And we just GA'd Postgres and MySQL. We didn't touch the engine. We run as a community edition, and it runs on same platform. So just out of the box, you have same performance, scalability, and the security. With a SQL, you can actually deploy at a single database. You can create a single database, elastic pool. If you have your CFO want your guarantee don't exceed a certain number of dollars per quarter, what have you, right? Use elastic pool. We'll cap the resources spent and make sure it's shared across the databases in that pool. And our newest service in SQL database is called a managed instance. Provide you the isolation you need and the resource governance that's customized resource governance you want. This can deploy into your own subnet, and you don't have to share with anyone. And since you're a developer, I know we always forget to mention, we support all drivers. Because the TDS protocol is a standard protocol. It's been open protocol forever, right? So there's a Microsoft version of drivers. So there's your ADO.NET and JDBC, ODBC, we ship. And there's many open source. And drivers connect to SQL DB and SQL Server. So write your application of language your choice, right? And we just, as I mentioned earlier, we released our Spark connector. And you can write your big data, whatever you want to do in Spark. And you can actually connect to SQL through Spark. We run on Linux now. OK, HADR, I thought I'll show you really quickly. Think about if you have to build this yourself, right? This is all built in. So we have a quorum cluster model, shared nothing. And for every single node, just say we have because you need minimum 3 to have quorum, right? And they all in different fault domain. They will be in different racks. And all of these are automatic built in. So if anything happens, and we will failover, know how to failover the other data center because every single database is automatically backed up and copied to a we call it a geo-pair region. So if there's really some natural disaster hit, right, half of the US for whatever reasons, earthquake or something, and we have East and we have other countries. And if you look at the view as it's very big, right? In data center, we have multiples of these database clusters. It's a service fabric rings, right? This excessive scalable cluster on application fabric. And each of these rings has a minimum 700 nodes upwards to 1,500 or 2,000 physical nodes, right? So, and all the connection will come through and the control rings will tell you where it is. But for application connection, we'll go directly to the database. Does not go through gateway. That's why the performance, we can reach that kind of performance. I showed you earlier. There's no gateway path. At the very early days, back in 2010, we had a gateway. Then we realized the performance is not good. So we actually scrapped that architecture, redid everything. There's no gateway, right? It's a direct connection. So if anything happens, we'll first pick whatever in that cluster. There's thousands of nodes. Which one is available, have enough room, and we'll move your database over there automatically. These are automatic, right? There's no human involved, right? If the whole ring is gone, we'll go to the next ring, and we support AZ as well. For if you choose to availability zone, if you choose your database use the availability zone, this ring will actually stretch across multiple data centers. So all this, actually, we actually end up saving more money for our customers. Because it's a PaaS, we have lots of telemetry. We help you to do performance optimization. This is automatic tuning, it's all turned on, right? Autopilot, or Larry Ellison called it autonomous database. We've been having this in production for years. And what actually PaaS can do, we don't talk about it enough, is when you actually run your workload in SQL in a VM. VM is actually a machine. Machine is a very coarse-grained container for your application. So how do you actually size and provision that VM? You have no choice. You have to provision the peak workload, right? You don't want a peak workload hit and your machine run out of CPUs. And in PaaS, because it's a shared platform, we can be elastic, right? We can actually take advantage of multiple workloads running on the same machine, and they can share the CPU resources. And because of that, we actually recommend, this is our IT example, right? Because generally our customer doesn't really want to share the real data of how they're running their platform. Our IT moved about 5,000 databases into PaaS and the SQL Azure. And they've been running for about a year. And we have some API, basically similar model as the performance tuning. We call it cost optimization. And we provide recommendations to tell them how to actually downsize. They're generally all databases. We see all databases, majority of them oversized. They don't really need that big, right? Because each database will take resources. So over the course of 16 months for the 4,000 database, they saved $3.7 million. That's a significant amount of money to their bottom line. And our IT is happy, our CFO is happy. So they're being continually moving more database into Azure SQL Database PaaS service. So not all. This is the early preview where we generally always being asked, when are you going to scale out? When are you going to scale out? And we are scaling out. So this is what the SQL architecture looks like today, right? Running on one box. We scale out the query, MPP, and on the query layer, right? But also there's a storage part. Right now, your machine could run out of space. So we're scaling out SQL transparently. We're going to have new architecture, new database architecture, and which is a microservice architecture, and everything going to be distributed. So theoretically, we can, please don't tweet this. And we're going to, don't tweet it, thank you. So we're in technical private preview right now. And so we have a long list of pipeline customers. And we will actually, we're aiming to go public this year, this calendar year. Yeah, thank you for don't tweet that. So we have lots of customers. What's that? I'm on the sheet. You're on it? Okay. Yes, because the database actually doesn't get smaller. We realized we started on this journey of, we said, that's it. We're going to do the hard work, scale out the database without compromising performance. That's the hard part, right? No compromising of performance. We're scaling everything out, running on these little 2-socket machines, but we're going to run very large database, means 100 terabytes of database, a single image database, and without the big machines. So we have to redesign everything with the SQL Server Engine architecture. So we got lots of customers. And because everybody got logo slides, so we put some logos up there. But we're going to do deep dive on a number of customers. So we're going to start with a customer you can talk to. Not ready? You're going to start? OK. Oh, Skype's not working?
He's still on his way.
Oh, OK. There we go.
Thank you, Lindsay.
Thank you.
OK, can you folks hear me? Yep. Thanks, Lindsay. We'll start with different customers first and come back to Financial Fabric. So we have a very large rental car company we are working with. And one of the challenges they have with many customers are seeing is how do you move to Azure seamlessly? And at the same time, if you have the biggest differentiator Microsoft has as a data platform is the hybrid platform. And as Lindsay mentioned, whatever you see with SQL Server running on-premise or Azure SQL Database is the same engine. So you can move your databases between these two services seamlessly. But there are also a lot of scenarios or customer workloads where you need to keep data on-premise as well as some applications run on the cloud. So how do you build this hybrid system? So this is a challenge this customer came up with. And one of the applications they were looking at is the Dynamics CRM. So they wanted to move from on-premise Dynamics CRM application to the SaaS version of Dynamics, which is Dynamics 365. So the two requirements was how do you move the databases from on-premise to Azure DB? And secondly, they had a lot of legacy applications which still needed data from that database. So how do you connect those legacy applications to the database? So we look at what they did. So initially they had Dynamics CRM on-premise running with SQL Server on-premise. And then they used what, I'll talk about the service shortly. So we have an Azure Data Sync Service. It's currently in preview. Think of it as a way to logically replicate your databases. You can pick and choose your tables and columns you want to move. And then they use that to move the databases to Azure and pointed the Dynamics 365 application to the Azure SQL database version. At the same time, they had Teradata and a bunch of legacy applications which are on-premise, and they could not move these applications to the cloud. They wanted to stay on-premise for these. So how do you enable connectivity between this? So since they no longer have an on-premise database, so what they did is they set up data sync, and they set up data sync between the on-premise databases for basically only one copy of the database, and then connected between the database and that. This way, they are able to use Azure SQL DB for Dynamics 365, and then they're able to connect their legacy applications and Teradata to the on-premise. And data sync is a service which is currently in preview, as I mentioned. You're also able to set up policies there on how frequently you want to synchronize. It basically uses a hub and spoke architecture, and you can define, in case of conflicts, which side wins, whether the hub wins or the spoke wins. And you can do one-way replication or bidirectional replication, meaning if you want to have a central copy which is distributed to multiple servers, think of it like if you want to have a single database or a single set of tables which every distributed location needs to receive. So the central hub can then distribute it to all these locations. And we have a couple of customers who are looking at using this data sync service to achieve that because they wanted to have a read-only copy of the database sent to different locations. Also, data sync service is the only option for you if you want to set up something equivalent to what you would do with replication on-premise. If you want to replicate databases on Azure between two Azure SQL databases, we would recommend you to use the Azure SQL Database Data Sync Service. In terms of best practices, today, if you have very large databases with more than 500 tables, the current limitation is when you set up the data sync service, you set up sync groups where you create a hub server and then all the child servers. So we limit up to 500 tables per database. So if you have more than 500 tables, we recommend creating multiple sync groups, and so that way you can say, you can basically shard it out, if you will. And in terms of permissions model, by default, it requires alter database permission, which requires control permission on all the tables. So we explicitly require you to deny permissions on tables which you do not want specific users to see. And there is a white paper on our docs website which has all the best practices for achieving the best performance, security, and also conflict resolution. So with this way, you will be able to set up your own replication architecture. And the best part of this service is you can go between on-premise and on-premise, or on-premise and Azure DB, or between Azure DB and Azure DB. So you can create all kinds of combinations, and it'll provide you that flexibility that regular replication provides. In terms of the sync, so if you can set up a sync schedule as low as 5 minutes to as high as in hours, depending on how frequent you want. It uses trigger-based logic, so the changes are kept in a separate metadata table which keeps track of all the changes that happen. And then depending on your sync schedule, the changes are uploaded to the hub and then distributed to all the other spoke depending on your architecture. The second customer I want to talk about is Thompson Reuters. It's a very big news and media agency, and they also do a lot of legal services, as most of you are aware. Let me quickly play a video of their experience with Azure SQL Database, and we'll dive into some of the things that they did to get there.
What we were tasked with was to build a highly extensible, scalable system.
Challenges like this are what we live for as developers. eBilling Hub is an automated e-billing solution developed primarily for law firms to automate their billing cycles. Our ecosystem for e-billing was growing at an alarming rate. We transact about 4.5 million invoices per year. So we decided to move eBilling Hub to the Azure cloud. Migration to SQL Azure was seamless. We were able to scale up the database on demand and share our workloads across multiple subsystems.
The invoicing system deals with highly complex invoice data, a very complex set of rules. If there's any untimely processing of this data, then people aren't getting paid. We developed a pure pass solution, leveraging Azure artifacts such as storage queues, SQL and NoSQL storage. We use machine learning to analyze the data that we're gathering to gain insight into our market behavior.
The benefits we saw from the Azure migration was almost immediate.
Managed Azure SQL services have been an instrumental part of our success.
We were able to process about 74 validations per second. And in one instance, the billing guideline validation was able to validate 28,000 invoices in less than 2 hours, which would normally take about 2 days. One of the biggest business values is the ability to go downstream and target the 27,000 Thompson Reuters customers who are yet to avail the e-billing service. My team and I are really excited to be part of this transformational journey that's changing the landscape and also helping us grow the business.
Okay, so you heard from the customer on their experience on migrating to Azure Database. So let's quickly look at what their application is and the architecture and the final architecture they ended up with. So just to give a quick background, the application they chose for the migration is eBilling Hub. So think of this as a billing system for law firms. So today, if let's say you're a big corporation and you solicit legal services from a law firm, how do you exchange your lawyer fees and lawyer contracts and negotiations and do all the validations electronically or digitally? So they wanted to modernize their system, which is currently running on premises, and this provides efficiency and scale for their customers as well as their business. So if you look at their current on-premise architecture, the e-billing is like a SaaS service, which is on the center. On the left side of this is a list of all the applications that different law firms use. So there is no industry standard that everybody is using a common law application, which is very common in most enterprises today. So depending on the law firm, they can pick and choose from a variety of options, as you can see on the left. And on the right side, their clients can also be on different set of systems. Let's say, for example, you're a company like Microsoft. You could be using one or more of these applications on the right. So there are two challenges here. One is the the two applications need to understand the protocol between each other, the schema and all that. And also, how do you make sure you can unblock communications between this and reduce human involvement? So these are some of the big challenges they wanted to prevent from happening. And at the same time, how do you grow? I mean, as they want to expand their business and bring more law firms or more clients into the mix, this matrix can just explode. So how do you simplify that? So, so you can see that they had today more than 15 plus applications on the left and more than 40 plus applications on the right. So the matrix becomes very complex already. And they were already, as you heard on the video, processing more than 4.5 million invoices per year, and they wanted to expand on that. So the first thing they did an assessment. So this is something we recommend, and you may have heard of the data migration assessment tools and services, which are free to use. So one of the value add of these services is to help you assess your current on-premise footprint, to understand what could be technical challenges that before you move to the cloud. So it could be because you have legacy application using really old code, or it could be because there may be some features which are written differently in Azure, so you may have to tweak your application. So amongst the 4 biggest issues they saw, which are highlighted on this slide, the first thing is they had some legacy code which were referring to old data types like ntext and text, and we recommended them to change them to the new var binary or ncar max. The second thing is the singleton database. Azure SQL DB does not have cross-database joins, so you will have to use reference to external tables. Think of this like setting up similar to link server, but not the same thing. And you will have, that's the only way to accomplish cross-database queries. The third thing they needed is the entire Azure infrastructure runs on a single time zone, which is universal UTC time. So most applications which are running on on-premise data center, you're running a system clock, which is most likely your own local time zone. So how do you factor that in? Because especially with e-billing hub, since it's a billing related application, it's very time dependent. So because you have to calculate hours to be billed, etc. So they had a very specific need that the application needs to run on a specific data center with a specific time zone. So we do have options. So you have the add time zone T-SQL functionality, where you can go and say, convert the time to at this specific time zone, which will do that. But guess what? They had 23,000 stored procedures they had to go and change. And there could also be changes that may be required inside the application. So the last thing is, there is no SQL agent in Azure. So you have what's called elastic jobs, but it requires you to rewrite your hundreds of thousands of jobs to factor. So these are some of the challenges they had. So at the time of their project, they had a deadline. They were running on a third-party hosted data center, and they had a deadline for cost reasons to basically move out of that platform, and they saw the value in Azure. So it was time critical for them. So if we had done the same exercise today, they would have moved to managed instance, because managed instance pretty much addresses all these issues without having you to change anything. So what did they end up doing? So they wanted to build a microservice architecture. So this provides a flexibility and scale, like Lindsay mentioned, basically breaking it into smaller services, so they are easy to modify and scale as such. So what they did is, at the lower level of this diagram is all the PaaS layer. So they moved all their main databases, the core e-billing database and also related accounting databases, and the validation rules, etc., to the PaaS layer. And then what they did move to the IaaS is, the first stage of their project was to move all their applications into virtual machines as lift and shift. So they moved all their applications into IaaS. And the only place where they used VMs for SQL Server are for 2 things. One is for SQL agent jobs, because they did not want to refactor to elastic jobs. And the second thing is, they had SSIS, and they had to run it in the VM so that they could do ETL between the databases. So these are the 2 reasons where they had to do that. So today, going forward, their goal is to move all their VMs out also completely. Like Lindsay mentioned, they do not want to be in the business of managing their platform. They want to add value for their customers. So they truly believe in the managed aspect of that Azure provides. So they're actually working now to move out of the VMs too. And with managed instance coming in, it unblocks them from doing some of these things which they couldn't do it last year. So with that, I will hand over to my colleague Joachim to talk about the next customer.
All right, thanks, Ajay. Okay, so we're switching gears just a little bit, and let's talk about the financial sector, and we'll focus on how Azure, the platform, and Azure SQL Database in specific can meet the demands of customers who are very security-minded. Now, we have quite a few financials already adopted, or who adopted Azure, but there's one that stands out in particular because they've been a really early cloud adopter, and the leadership team there has fully embraced Azure and all the services that Azure provides to build their platform, the Data Hub platform. So they're based in New York. Financial Fabric is a global provider of big data analysis and reporting services to hedge funds, wealth managers, and institutional investors. And like I said, they have their platform is called the Financial Fabric Data Hub, which uses quite a few services. And they are all about doing this with as few developers as possible so they can focus on what they're good about, namely doing financial analysis and analytics. And so they're using everything from Azure Compute VMs, they use Azure SQL Database with pretty much all the security features we're offering, including always encrypted, Active Directory, and so forth, to provide hedge fund managers access to the latest and greatest analysis that they can't or don't want to do in-house. So here's one more architecture slide. This basically shows the key component is the ingestion of information, and there's a lot of sensitive information, as you can imagine. And so what they focused on was to protect that sensitive information as soon as it comes in the door for as long as they need to when it goes out through the web portal and get consumed by hedge fund managers again. So with all of this, I am going to introduce you to the CEO and co-founder of Financial Fabric. Aha. Subra, can you hear us?
Now I can.
Excellent. So Subra Bose said CEO, co-founder of Financial Fabric. Subra, welcome to Build 2018. You're in our session here in front of a room full of developers, DBAs, and so forth, and we're hoping if you can share some learnings and experience from your development on Azure and Azure SQL DB.
Sure, absolutely. Well, thank you, Yahim, first of all. I will rather be in the room with you than being in the Columbus Circle in New York City, kind of stuck in traffic, but glad to be presenting virtually.
Great. So my first question to you is, can you talk a little bit about the Data Hub platform? I already said a few words earlier, and I pointed out that one of the things you guys are focused on is have most of your staff focus on your core value, your core business, like the analysis, and use as little development as possible to build your platform. So maybe you can share some experiences there.
Absolutely. So we are providing Data Hub to the investment managers at hedge funds, wealth management, and corporate treasuries. These businesses, as you know, probably all, that they are not just data-driven, but they are data-dependent businesses. Across compliance, risk management, client servicing, accounting, trading, portfolio management, you name it, all these businesses, the commonality is that they are heavily reliant on getting the right data, accurate data, in the right format to the right set of people at the right time. A lot of rights. So most managers do not really have the luxury of building a in-house data warehouse because of time and investment required. It's the industry across the board, the data exchange is hugely manual. Capturing, copying, verifying, converting data is laborious. Downloading data and then creating analytics is an everyday phenomena where fund managers or investment managers spend a couple of hours of their everyday morning, which is the prime time, as you know. So Data Hub is a software as a service, fast, comprehensive solution to data from across providers to produce consistent, comparable, and meaningful data for reconciliation and analytics for these managers. So for normalization, we use a standardized model. For access across the organization, we enable the Data Hub to the PCs, phones, tablets, you name it. And we also enable the end users to do their own analytics on top of the Data Hub. Now, how we have done it, right? You have asked how we have architected it. So we have used Azure SQL for our structured data. Incoming data files are stored in the Azure Data Lake or Azure File Store, and then gets ingested and normalized in Azure SQL. We have integrated with Microsoft Flow and Azure Event Grid so that end users can manage their data science workflows on their own. They don't need an IT project for that. Business users can connect to the Data Hub from Excel, Power BI, and other sort of BI tools. Our clients, data science developers or data developers, they can develop analytics in SQL, R, or Python. So in the Data Hub, we are covering the end-to-end of data acquisition, normalization, analytics, and visualization of data by using various Azure technologies and Microsoft stack.
That's great. I'd love to hear more and talk more about you, because I know we've always some interesting facts to share. But maybe, and we don't have a whole lot of time, is there anything about the Azure platform that, why did you guys embrace Azure, and what was your motivation there? Can you just share a few words?
Sure, absolutely. So, as a fintech, interestingly enough, we needed a lot of different functionality and deliver to our clients very, very rapidly and reliability. I mean, hedge fund managers have one thing in common: they have very little patience. You have to give something now. So we didn't want to write a lot of code from scratch. Azure platform provided us an ultra scalable platform where we could grow our business by integrating different software stack without worrying about the infrastructure, high availability, disaster recovery aspects. Just to give you an example, Yahim, you probably remember, we were running on SQL Server Enterprise, right? The on-prem stack originally. Yep. Mm-hmm. And it's a great database, of course. Between all of the providers, we selected SQL Server because of our familiarity from Credit Suisse days in terms of enterprise scale. But then when we were launching a service at global scale, you mentioned we should look into Azure SQL. So now we are on the Azure SQL Elastic Pool, and that helped reducing our costs significantly and provide better performance for our client. Migrating from SQL on-prem to the Azure SQL enabled our resources literally to focus on the business functionality as opposed to database cluster management and other things. So tremendous leg up for us.
Yeah, I remember. So this is great for sharing. Thank you. And I remember those sessions when you guys came out, and it seemed like no time passed between you thinking about what your platform, your architecture, and then all of a sudden we heard, yep, we're in production. We've got our first big customer. So it's great to hear. Unfortunately, we're out of time, Subra, but thank you so much for joining us. I know you're very busy. but we always love to hear from you, your next great adventure, and how things are progressing. So we'll stay in touch. Thanks again.
That's great. Yahim, I wanted to thank you and the team at Microsoft. One thing I will mention before parting, which is Microsoft has been great in terms of interacting with service providers and clients like ourselves. It had been incredibly valuable for us to get here. Thank you and enjoy the build.
Great. Thank you, Subra, and have a good afternoon. Bye-bye.
You too. Bye-bye.
Okay, with that, I'm going to hand it over or back to Lindsay.
Thank you, Joachim. So we have a little bit of time. One more customer story, so then we're going to go to the last part. So I want to talk about ASOS because ASOS is kind of a special, right? It's they're a fairly new company starting in 2000. When I first met them in 2013, and they built everything on SQL, on the SQL Server. And the business growing like they didn't wildfire, didn't expecting grow so fast because they have a little bit of special business model to targeting the young generation, right? And one of the things they do is fast. They keep fairly small inventory, but their basket, shopping basket, and the warehouse inventory, which is scattered all around the world, are actually doing synchronous transactions. So I know my teenager, when they wanted something, they want it now, right at this moment, and if it doesn't show up in the next 10 minutes, they move on, right? So need to be fast. They grow to have 13 million users, and it's not really small, right? And look at the numbers you have showing from ASOS. So I want to show this video quickly, if this works. No, that doesn't work. This works. Where did it go? Oh, there. Sorry.
ASOS wants to be the #1 fashion destination for 20-somethings around the world. Fashion is in our DNA. We have just over 12 million active customers, and we have 80,000 products on the site at any one point in time across over 800 brands, and we're introducing about 4,000 to 5,000 new products onto the site every single week. We don't have shops. People know about ASOS from the internet. We have 1 minute where that digital platform is out. We're not serving our customers. We want to be there for our customers 24/7, 365 days of the year. Over the last couple of years, we've embarked on quite a significant program of essentially rewriting our entire digital platform. And the reason we did that was scale, to change quickly and innovate for our customers, and to give a globally consistent service. Our legacy platform was all hosted in one data center in the UK. It wasn't designed with mobile first in mind.
There was two big design decisions. The first was adopt a microservice approach, and the second that we would target those microservices to the Azure platform. Our microservices are product, bag, checkout, order processing, payment, the things that underpin the shopping journey. To make that experience as fast as it can be, you want those services to be as near to the consumer as they can be. The Azure Platform as a Service capability gives us the ability to provide that globally consistent performance that we want for our customers.
The Azure leadership program has been brilliant, and for me the proof in that was our first Black Friday on the full new platform in Azure. We had 167 million visits. We had our biggest hour, our biggest second and biggest financial day as well. And we had literally no problems throughout the entire weekend, so that was a huge and a very important success for us. The amount of critical technical resources Microsoft made available for us leading up to that event and on that event was absolutely phenomenal. In terms of the future, our new digital platform on Azure is really just the beginning. We have so many more things we want to develop now. We want to start innovating in new ways through visual search, through voice search, through different forms of interaction. All of that will get developed within Azure. We've achieved something that was pretty challenging, and I'm really pleased with where we are.
We'll have this. Come on. So at 2014, they still built this entire application as a single stack application as service. And when I met them early 2014 and 2013, they were asking how to scale the SQL Server to support their business growth, right? We quickly got into the point. We talked about Superdome, new Superdome, right? That time the new Superdome is still just coming online. And then they realized actually going to actually hit their bottom line pretty hard. They end up need multiples of these Superdomes. Everything have to be state-of-art hardware to actually over-provisioning to support the growth. So with the entire stack from their customer device, web browsers, and to all the shopping bags, basket, and the inventory, and everything together going to be difficult to scale, and they have a starting building very big data warehouse, so they can actually service their customer better. So they actually made a pretty difficult choice, right, to re-architecture, to scale out, to make it microservice. There's actually a fairly long interview with Bob, their CTO, of their entire journey and how they actually decided to start to actually do microservice of the entire stack, right? Because it just simply scale any single component is not good enough. So this is their design goal. And the ultimate goal is that they need to be future-proof, the platform. As they scale, grow past the 30 million users, and there's still yet a lot more teenagers on the planet they want to service, right? So they choose to use Azure platform because they don't have to worry about the infrastructure scale. And they choose to continue to use the SQL Server because that's what the application is built on. And they use Elastic Library, Elastic Pools, to scale out the SQL. And with their application actually now built on scaled out microservice architecture, and our platform scale for them across the globe. So this is what the microservice architecture in the high level actually look like. They made the decision they're only going to worry about their customer, their business, and they're going to let the PaaS platform service taking care of everything. I tried to change that font, so everything from that dark gray box below, and they basically going to rely on everything Azure got to offer, right? With the centerpiece of all their core business data and driving their application with the SQL. So between the caching layer and the SQL Azure database scale out through Elastic Library and Elastic Pools, they're able to grow their database very rapidly and service more than 13 million customers. And the journey took them more than a year. It's quite intense, and they used the Azure, everything is using Microsoft platform, Visual Studio with Azure integration, continued integration deployment, actually enable their hundreds of developers to write code and the developer to staging and to production continuously. And so first time ever is the Black Friday of 2016. And 95% of based all their workload on all the shopping basket, everything worldwide is all in Azure. That's the first time in Black Friday is completely running in cloud. And it's quite nervous for everybody, but we actually end up come out with the flashing colors, and everybody's super excited from this point on 2017. And Black Friday is a huge success as well. They have since moved their payment system to cloud as well. So they don't actually need their on-prem data center anymore. They're shutting all those down. So with that, we're going to talk about business model. So now you actually know how to budget and plan to use this wonderful platform. Thanks, Alan.
I'm going to go over the new. It is on. Hello. There we go. Okay, so I'm going to go over the new business model. We launched this probably about a month ago, if not a little bit more than that, for Azure SQL Database, and it originally launched through what was part of Managed Instance. So this is a new way for our customers to purchase Azure SQL Database, and essentially the biggest reason we introduced this was for flexibility and transparency. So what it allows our customers to do is they can now map one-to-one what their cores on-premise look like for moving these up into Azure, because we now expose a core and storage model, and those two axes can scale independently. So you can scale storage without scaling cores, or vice versa, depending on your workload. So if you look, there are two specific tiers for this. The general purpose tier is where we see most of our customers will land up, and the sort of what we see there is it will be the best option for almost all workloads, unless they require high IOPS and sort of high, the always on replicas that you can get there with business critical. With a new business model, you'll have the ability to scale anywhere between 1 and 72 cores for single and elastic pools. Managed instance will scale in sort of different increments to that, but the key things that you need to note from this slide, it is quite a busy slide, is between the two different models that we have, some of the major differences you'll see are in the availability. So with business critical, we'll make 3 replicas available, of which 1 is a read scale for customers. So if you think about the implications of that in sort of managed instance, and this will also come to single DBs, you will be able to offload your read analytics workloads into a secondary without affecting the database where your transactional workload is running. The kind of the whole thing that drives a lot of this, I think we're going the wrong way, is we've now sort of introduced, as part of that, we understand that a lot of our customers have already invested in SQL Server and sort of have licenses for SQL Server. So prior to this, we had what was called license mobility. So you could move your SQL licenses from on-premise up into Azure for VMs only, but we now allow you to take those same licenses and you can offset them against the cost of platform as a service deployments of SQL Server. And that's all part of the Azure hybrid use benefits. So you'll see that on average, we see about a 30% decrease for customers that are using Azure hybrid use benefits. And ultimately, what it's going to allow you to do is for every standard license you have, you can bring that across into Azure and offset that against 1 core in the new business model for general purpose. If you have an enterprise license, that'll be 4 cores in general purpose and 1 core in business critical. And through these mechanisms, we're making it easier for our customers to continue sort of using those investments they've made with SQL, with the one caveat that you have to have software assurance on those licenses to do that move with them. And that's kind of the end of the new business model and the vCores. That slide's just at the end there. We'll take questions.
I think we got to the other slides. I think is missing a slides there, because the AHub does support Azure SQL database now.
Yes, I did mention that.
Oh,
Yes.
just there was crowds on the line.
No problem.
So yeah, we have a few minutes, so we can take questions. We have 5 minutes, we can take questions. The reason I put this up as wrap-up slides is this is the latest article on enterprise cloud, public cloud from Forbes, right? Actually rated Microsoft Cloud, Azure Cloud as #1, because we've been actually working with enterprise customer for 20-some years, for a very long time, right? So these are our customers we're familiar with, and there's also lots of new customers so we actually get to meet, right? So we actually share learnings, share experiences from existing and old customers. Is the question?
Hi, I have a question about the ASOS architecture slide that you presented.
Yeah.
In that slide, there is a sharded Azure SQL database.
Yes.
Is sharding built into Azure SQL database, or is it at the client level?
Sharding, we have a sharding library, and we have so on the client side. But because of sharding, the difficult thing about shard is you need to decide the partition key, right? This is actually, you look at anything, these distributed partition product, Doesn't matter SQL, no SQL, you pick partition key. Right, so what we have is the shard library management is building the SQL Azure. We manage the shards for you, the shard map, and you choose the partition key and you integrate the Elastic library with your app.
Oh, I see. Thanks.
Okay. Yes.
When is the vCode model?
It's already there. So yeah. But the price, nothing changes really. No, you repeat.
So the question was, when will the vCore model become generally available? So it is currently in preview on the portal, but the pricing that is there will be the same pricing that we're going to GA with. So if you start using it today, that'll be the same going forward.
Yeah, so the GA and the preview thing is a little bit interesting in this particular case. We really just changed the business model or changed the price, right, for certain performance tiers, and so change the way you buy them. And as our general practice, we have to go through preview period, but nothing really will change when GA, so consider GA, yeah.
When is managed instance going to be generally available?
Yeah, good question. So managed instance right now is in public preview, and also little known fact, it's actually in production support. We have customer in production, and you can call CSS, your premier support, open support ticket.
But what about SLA?
We provide we don't actually, we have a same SLA for HA, DR, and the difference is if when we're GA, if there's SLA we didn't meet, you get credit back, right? In the public preview period, since we don't have contractual SLA, and we will try to fix it as soon as possible, there's no giving back credit because it's at 0.5%, half price.
But any idea when it's actually going to be in general availability?
Yeah, it'll be this fall, yeah.
This fall?
Yeah.
And will the price be the same or it will increase?
Price will be increased, right? Because the preview price right now. Yeah.
Okay. And one more thing. Any plans to increase the limit of 8 terabytes for the managed instance?
Is any plan to increase beyond 8 terabytes? So there's 2 fronts at the GA. We should double that. So we're expecting 16 terabytes or more.
Okay.
And with earlier, I showed the scale out architecture integration. Hopefully that we're shooting for 100 terabytes. Yeah.
Okay. Thank you.
Thanks.
Is there any guidelines of when to use the data sync feature you showed, as opposed to the other like transactional replication or other options?
Yeah, I can take this. So data sync will work for Azure SQL database. There is no transactional replication available between Azure databases. So that's the scenario we recommend. So if you go look up for Azure Data Sync Service, the documentation actually calls out all the specific scenarios where this will be most beneficial.
2 basic questions. Starting with the work you're doing for the scale-out database architecture, does that mean we really need to do sharded databases in the Elastic library anymore? Will that be kind of virtual now and automatic, or do you still say use the Elastic library to do sharding at that level?
So the question is, if the database scales out already, do you still need to use Elastic Shard library? So there are actually advantages if your application can control the distribution, right? And if you rely on platform to scale out, you have less control. You can use combination of both, right? There's sometimes each shard is small. There's advantage of it. If you just 1 terabyte a shard, it's a lot easier to manage.
Okay. Other question, it's unclear to me with the availability zones what I actually need to do to ensure disaster recovery if a whole data center goes down, right? That you have the whole replicas within a data center and the fault domains, but do I need to manually create my own failover groups to do that, or is that something kind of built into the SKU where I can say I want high availability across availability zones to make that happen?
Okay, so do you want the answer? Do you want to answer it? Okay, so the availability zone, you don't need to create availability groups. So it's availability groups automatic thing. And in order for you to take advantage of the database is with availability zone support, you actually, when you create the database, you need to select for AZ support.
Okay. Thank you.
Sure.
When is Socrates going into preview, and what's the boundary to Data Warehouse MPP?
What is the question? Oh, so first of all, we're in private preview right now, and we don't have final date on the public preview yet. So I can't answer how to compare to Data Warehouse. So this is designed for transaction workload. So if your workload is a Data Warehouse, I don't think you need the scale out storage layer as a single image, right? And so you should go with Data Warehouse.
Well, it's kind of, if you're implementing a data vault, you can choose either way. You can choose a data vault implementation using MPP, or you can do one in SQL Server on-prem. But you couldn't do it in Azure SQL because of the fact that you couldn't scale the platform. But now you're saying you're doing scale out, so a data vault would work in that implementation.
I have a hard time hearing. Can we take it offline? I'm having a hard time hearing your question. Okay, thanks.
The acoustics are not very good
Yeah.
here.
Can we have maybe we can have a couple more questions. Go ahead.
The data sync preview, when is that going live?
So we are expecting it to happen later this summer.
Okay, and is it the
GA?
same? Yeah. Is it the same one? I know there was one available around 2013.
It is the same one, but it's been changed so much that it doesn't look the same as what it was 3 years back.
It's been rebuilt, yeah.
Yeah.
It's been rebuilt, and it's part of SQL deployment, and
Yes.
the portal and architecture, everything changed.
But it will give me the same functionality.
Yes, it'll give you the same capabilities if that's what you're looking for.
And will it have to be the two same level databases, or can they be of different levels?
It shouldn't matter. So this is a logical level replication. So what you choose underneath should not be a question.
Thank you.
Short problems. So I understand with the implementation of an Azure SQL database, you have 2 replicated copies for HADR. So with that in mind, beyond the availability of having an active passive where you can read from the passive, what other scenarios would you look to use the geo-replication feature, since it really isn't necessary for HADR?
Active geo scenarios?
So the default HA that is built in gives you local data center fault tolerance, right? But for your business applications, if you need to either do read scale out, where you want to offload your readable workloads to a different replica, or if you want to protect yourself from data center level outages, then you would use GeoReplica.
So I took away that you had data center replication outside of data center as the 2 backup copies for your Azure SQL instance.
Yep.
So, right, okay, so geolocated 40 miles apart, but barring a major disaster recovery, right, like a bomb going off in DC or whatever, right, outside of that, that would be the...
So if you can be assured that that will not happen, then you don't see the true
Sorry,
value.
that's an argument I'm having with my DBAs, idling active georeplication,
But
they're pushing back, so I'm just...
Yeah, the bigger value is you get readable secondaries for your applications.
Right.
And you can set up failover groups where, just like listeners in on-premise, you can do that so that you can move your application as a unit, even if there's intermittent glitches on your local data center.
Perfect. That was the confirmation I was looking for. Thank you.
Yeah, I do have one more comment about
There's
that.
one more important aspect, actually. This is to bring the data close to where you are. So if you're a globally distributed enterprise and you have sites all over the world, then GeoDR allows you to bring the data to where your customers are, to where your in-house employees are, and so forth. That's another aspect that people tend to forget.
Perfect.
Yeah, exactly. So for example, Stack Exchange, and they actually use the GeoActive as data CDN. You know the content distribution network? Normally you have your page static, right? And as Yakam said, you want your data closer to your application so your page can be live, right? So that's what's actually one of the scenarios people tend to forget is you need your data close to your CDN network, to the edge. So one good thing SQL will do is bring data to the edge, both in cloud and on-prem, right? The IoT edge, we have devices running SQL and can synchronize.
This is less a question, but more a push to finish a feature you guys started, but didn't quite get over the line, which is Azure AD Auth. It works for classic.NET, but there's no .NET Core support now. And the rest of Azure is pushing us to do managed service identity and other things. And so without that, we have SQL rotation passwords, password rotation, and all this other hokey stuff we have to do. So we really want that like yesterday.
So that's a great segue. Actually, I was hoping for a security question. Now we got one. So Jakob and I we have a session later this afternoon, 3 o'clock. I forgot where it is, but I'll be happy to chat with you. I know there's a couple, I've heard from others, so we'll address that, and we'll be happy to talk to you offline a little bit about your pain points there.
Thanks.
So, yeah, thank you.
Thanks, everyone, and fill eval, please. Thanks.